paar andere Verhaltensregeln, damit die Zeit haben, sich hinzusetzen, ruhig zu werden, und dann kannst du anfangen, würde ich sagen.
Okay.
Welcome for the talk Making the Linux Kernel Better Without Coding. I would ask you, if you want to leave during the talk or during the question and answer session following the talk, please make sure to leave quietly so the others have a chance to listen to the talk or to the question and answers. And especially if you leave through the lower back doors, please make sure the doors are shut after you, because otherwise it's quite loud in here. Thank you. And thank you, Wolfram.
Okay, hi, welcome. Thanks for coming to my talk. First things, a few words about me. I'm a Linux kernel hacker. I do make my living with that, but besides that, I'm also a passionate hacker, so I also do it in my free time and like modifying the kernel. I happen to be the current maintainer for the I2C subsystem, which is a bus which is needed inside computers and embedded systems, and I take care about the master drivers. And I do like to share my knowledge about what I find out when hacking the kernel, and I really like to enable people to participate in basically free and open source development, but especially in the Linux kernel, because I don't think it is that hard to hack on the kernel as it is always said to be. It has some things you should know, but other than that, it is also a piece of software which is written in just C, and so it is possible to hack the kernel. And in this talk I want to share some knowledge where you can even contribute to the kernel without knowing how to code at all. One thing I noticed so far during this conference, I really do like muted devices during talks, both as a speaker and as a listener, so I'd really appreciate if you could silence your devices. Thank you very much. So what is this about? It can happen when you set up a project and maybe you want to monitor something with an old computer, and then you grab into your hardware box and found this old webcam that was cheap, you don't even know where it came from, but you just have it. And you want to plug it in and see if it works. That's what I will actually be doing. This is a special talk for me because I will be showing quite some things live, and so you have the extra thrill of things failing here with me. I plugged in the camera. Now I want to start some camera software. Hope to get a picture, and I just get this very frustrating message. Please sure make the camera is connected. Yes, it obviously is. I can assure you. And make sure that the correct driver is installed. And this is the problem we have. There's no driver for this camera. The good thing is, as it is a very cheap camera, there are other variants of it already out there, so chances are pretty good that Linux has a driver for this camera. It just does not know about this concrete instantiation of this camera. And this is what we're going to teach Linux here during this talk, and how to get the necessary information, how we can convince Linux to support this camera. So this is how it all starts. I just repeated the error message again just in case the back rows could not read it as well, and we're going to fix that. The first thing is obviously to know more about the camera, and names do not help very much. We need a unique identifier, which in case for USB devices is a USB ID. PCI devices have something similar, and so you can just run these, probably you know them, commands to find out about the USB ID or PCI ID, and if there's a name connected to it. If the output of those tools give you a name, that does not necessarily mean there's a driver already for it. Those two databases, the Linux drivers and the USB ID list, are decoupled, and This is the first part, the first thing where you can take part. Because for developers it is very, very useful to know which USB ID has which name. So if you have a camera, you type this command and see, hey, it does not show my camera name. There's a way for you to submit additional information. I've mentioned here 2 websites which have 2 ways of contributing data. You can log on to the website and enter a web form, submit additional data, say, hey, I've noticed that LS USB does not list my camera. This USB ID with that product ID has that name, and it will be included somewhere later. If you know how to generate patches, you can also send a patch to a mailing list. I will show you this is an example. Oh yeah, that does not look very pretty. This is basically the website. It's not very pretty, but it's very effective. And you see that you can here add IDs and stuff like that. Not very complicated, yet very useful for developers, because developers do not have a lot of cameras. So if you have hardware which is not detected by LS USB, I would really encourage you to go there and add that string. This camera has that name, and developers can benefit from that. Next step, if you found out the ID of that camera, obviously is try using your favorite search engine, using that ID number, maybe the name and probably the term Linux, and look for additional information. You will usually find out a bit internals of the camera that might be needed or not. Usually you get results from distribution forums, which may contain useful information, but what I want to mention here is that you really have to watch out if the forum entries are like 2 or 3 years old. Sometimes they mention that you have to compile an out-of-tree driver from that SourceForge page or so. This is usually not the case anymore. Most drivers are included in the main Linux kernel, so it's not so complicated as it sometimes looks if you Google around. So try to get information, but try to think that these information might be outdated. What I find very helpful when adding this kind of hardware is get the information from the Windows drivers, which are usually supplied by some CD, or you can still find them on the web. And besides the binary blobs, which are totally uninteresting for this case, there's also an INF file, which is a text file describing the driver. Of course, drivers usually come some kind of package, so you might need one of the classic ones, unzip, unshield, to get rid of the packing headers. I found out that in most cases I even had to use Wine to really install the drivers to somewhere. Sometimes it even fails to install the driver properly, but still you can get the inf file from that in the locations I wrote down there. Where's the mouse cursor coming from? And so they're still available. And they're simple text files, and we can parse them. And they show that most of these camera drivers, even also on the Windows side, are pretty generic. There's one driver handling all sorts of cameras, and somehow these cameras are described in those files. Or at least relationships where you can guess, okay, this camera must be similar to that one, or even the same one, just with a different case. And there might be some other hardware relevant infos in there. There's one example from another cam where I once added support to Linux. And you really don't have to understand the details of that the first part is some kind of name of the descriptor, and the second part is registering the actual USB ID, which for the camera we want to support. The nice thing about here is that it gives a relationship. The red numbers, also on the next slide, the red numbers are the USB of the camera we want to support. That's our target. And the green number is a new information. So hey, that's a camera we know must be somehow similar to the camera we want to support. All fine? Okay. And just that those USB IDs are mentioned in one line gives a good indication that they are very similar. This is the camera we want to support, and even in the Windows driver the descriptor has this name. And so we could, I back then could add support for this camera, which was some Hewlett-Packard camera, using the information for that camera, which was, I don't know, some cheap, I don't know, company, probably Chinese. I don't want to say Chinese people do always cheap stuff, but in that case it was really the case. So, with this camera it's even a bit more luxury. We have lots of lines and with lots of USB IDs, and they, as a comment after that there was even written some internals. The first thing is the camera chip, and the second is the sensor. So we can easily spot, do we have some similar or exactly the same entries with different USB IDs. So we gain the same. This is the camera we want to support. This is the Genius something. And this is the camera where, which is exactly similar, exactly a rebranded version of my camera, which is some micro dia, I don't know what. So what we got is a similarity. We know the camera we want to support, and we have a camera which is similar. Now we need to find out, is this new camera or this new ID already supported by Linux? And there we can use a handy web service, the Linux Kernel Driver Database, or short LKDDB. So if you enter the new ID we found out together with the search term LKDDB into favorite search engine, you will get information if this is supported by which driver and some extra information about that driver. And this is what I wanted to show. So I'm opening a new tab. I use Google, I enter 0C45624C. I typed this a lot during the last days. LKDDB. Yay, we got a hit. And this is from the database. Lots of generic information, including listing all supported USB IDs, so you can tell it's a pretty generic driver. Here this is all different cameras which are already supported, so it's not surprised that it's probably supporting yet another unknown one. The key information at the top here for us is the driver name, the module we need to load in order to add support this driver with our camera. This is what it's called, GSPCA SN9Z20X. Now comes a neat trick which is in the kernel for quite some time, but it's not very well known, that you can at runtime add a new USB ID to a driver and it will feel responsible for it. Every driver has a static list of drivers it feels responsible for, but you can extend this list at runtime. So first we go into super user mode so we can load modules, kernel modules. Remember, the driver is not loaded yet, there's no device it feels responsible for, so we have to do this manually, loading the module. Once we have the module loaded, the driver will get an entry in sysfs. It's system, bus, USB drivers. It's long, but it's kind of logical. GSPCA, the driver name, basically. And there's this file new ID. It's a regular file, and you can echo a USB ID into it. And the driver will start feeling responsible for that and making the best out of it. This works for USB, PCI cards, and if you still have it, PCMCIA cards. And it's pretty good for testing new hardware with current drivers. And this is also one thing I want to do live. But first, is that readable in the back? Oh, yeah, hooray, yeah, last row says yes. So, GSPCA SN9C20X. CD sys bus USB drivers, GSPCA. So here we have the file new ID. I'll make it a little bit smaller. I hope it's still readable, but I need more time. Still okay? Okay, thanks. So, and this is the ID of our camera, where we found out which driver should feel responsible for that, and we echoed into there. Okay, let's see if something happened. I have another desktop where the varlog messages is being logged. And we see, okay, registered, GSPCA is probing, that's good. Oh shit, it failed. Yeah, that was for this talk expected. That's one nice thing of the Linux kernel. It's free and open source software. I have given this a similar talk where exactly this pattern was needed and support was added. But there is a problem with generic drivers. Yeah, we did that already. Generic drivers need parameters. The camera chip is supported, but they support also a variety of sensors. So it needs stuff like which sensor do we have, at what address does it live, and does it have special flags. And if the parameters does not match, the driver will fail. And this is what exactly happened here. It worked for me when I tried it with the last cam, but with this cam it failed. Not bad. My computer still lives, and I can assure you the camera still lives, so you can really try around things, and the chances that you break some hardware is very close to zero. So just play around with that. If you try to add hardware, don't be too afraid. So no, I had the problem. I had my talk accepted, I had the camera, and still things did not work. So what did I do? I made it work. I sent some patches to the Linux kernel, which are accepted. Meanwhile, they're already upstream. So I'm running here a kernel which is like 3 days old or something. And this introduces the concept of a reference ID. Remember, we found out that there is a camera which is very, very similar, if not identical, except for the casing, to this one. So I should be able to say to the driver, feel responsible for that USB ID and use a parameter set from that USB ID. And that is what I implemented. The first line here is, of course, if there's a new ID, there's also a remove ID to get rid of, like here, broken entries. This is what we do. First, we get rid of the broken entry. And then we say to the driver, feel responsible to that USB ID, 0, well, we could assign a USB class, we won't need it here, we ignore it, 0. And use the driver set for that camera we found from the Windows driver. Let's try that. So, echo remove ID, echo no, 7045, no. Let's check again. I think this is correct. Okay, there was a slight delay before the prompt returned. That gives some hope. Let's see the last lines of the output. It's probing again. Oh, and it has a sensor detected. That sounds pretty well. It also created an input device, so that's a button on top of the camera. So this, pardon? Oh, just the last lines are needed. Yeah. Oh, you can't see them. Oh, sorry. Okay. So that gives hope to start the camera program again. And here we go. We have a camera. So that was no C knowledge involved. It was echo, it was sudo, and just a bit of knowledge. Okay, it's not very obvious knowledge, I agree. But this is how people can add hardware to the Linux kernel, because as a developer you only just have a few cams, you can write the driver for that, but you can never have the bunch of hardware which is out there. And this is also some kind of crowdsourcing. Users have all kinds of hardware, and so with such mechanisms we can make the Linux kernel support hardware, even more hardware than it already does. I mean, it's pretty good already, but we can still be better. So now the camera works for me or for you, but it wouldn't be free and open source software if we were keeping that for ourselves. What to do with that knowledge? If you're not into programming and creating patches, it's totally fine to write a mail similar like this. Yeah, I found this out and I don't really want to create a patch, that's all too complicated for me. Here's the knowledge, can somebody do something with it? That's perfectly fine. I'll give you some seconds to read it. The key question here is whom to send the mail to, so somebody feels responsible. And there are some hints. The first is there's a command modinfo, which will give you module authors who wrote the module. You could have a look into that. You could have a look at the beginning of the source file, and the nice thing about LKD, the Linux kernel driver database, has links to the source file, so you don't even have to have the Linux kernel source installed. I just want to show that. Here's the page again, and if we go down, you see here it has a link, drivers media USB, and then we have a link to some cross-indexed source file, and then you can probably find here some email addresses as well. And if you're interested in knowing a little bit of coding, you can just also have a look how this driver works, what it does, what it maybe does not, if there are fixmes in it, and just have a look how such a driver looks like. It's not rocket science. If you have kernel sources installed, there's a nice script in the subdirectory scripts. It's called getMaintainer. It will give you a list of people, simply print a list of people who you should have in your CC from the mail. I use it myself when I'm creating patch series. It's a good tool, very useful. When in doubt, always use a big famous LKML mailing list, which I wrote down there. And to be very sure, just add me, and I will track if somebody from the subsystem will pick it up, and if not, then I will just create the patch, because it's a low-hanging fruit. It's totally okay if you say I don't want to do it, but you could even try. If not, I say it's a low-hanging fruit, I will do it. Again, obviously, the camera will work for you. The camera work for the rest of the world, when everything went upstream. And if everything went proper and there is a patch entering the Linux kernel, you will be credited like this, reported by, and then you have your name in the Git history of the Linux kernel. For some don't care, for some it gives a warm and cozy feeling, so you decide. So you could stop there, or you could move on. Next steps, possible steps, I don't want to talk in detail about here, are create the patch yourself. I don't give any pointers for creating patches here. There are lots of them. One comment I want to make is that you don't necessarily have to use Git if you want to create a simple patch. If you want to do serious kernel hacking, I really recommend learning Git if you don't know it already, but for such simple patches you can do like Quilt or other more basic patch management software. That's totally fine. There are how-tos, how to work with that on the net. You will easily find them. For kernel related stuff I added 2 pointers. How the kernel development process works in general and what you should take care when submitting patches. I think it's worth reading even if you're not deciding on continuing working on the Linux kernel, but some of the rules are pretty good for, I think, most software projects. It's not necessarily that every project should adopt the exact kernel rules, but it gives you an idea what should be proper, what should be formalized to be working on a large-scale project like the Linux kernel. And if you do code, then you could also try and playing around with the driver. When I first got the camera, I noticed there's an LED, it does not work. So one idea would be to check why this is a simple thing. You could check the driver, where the LED is controlled and what you could do about it. To be honest, this problem is already solved. When I traveled to Brussels, I had some free time in the train and I found out why. So I'm sorry, this is already taken. Or stuff like the camera can get pretty slow when there's not enough light because it has automatic exposure settings, and other cameras have an option to enable and disable automatic exposure. So you can disable it so the camera will be faster at the price of too light or too dark pictures. This camera does not have that. It has always auto exposure, so it tries to make the best out of the light, but it can grow slow. So you could try to find out, is there a way to control that? Can I have a button for that so I can set it on and off? That's how you could possibly get into driver hacking. Especially it's a cheap cam, you really don't have to be afraid of doing any greater damage. It's really good for playing around. Yeah, that was basically it. I like to have enough time for questions. So this is what the slides are. Questions right now. I will be at Fosdem until tomorrow noon probably. So if you see me, just approach me and ask me questions, or come for a chat, or, well, there's my email address. You can write me a mail if you have questions. So that was this for now, and fire away.
Yes, thank you for your presentation. And looking at what you are saying, I think it would be very valuable to have a script that you select a device, like a PCI device or a USB device. You provide maybe the execution file from the Windows driver, and then inside the script making the INF analysis, and to compare automatically to the database you show, and try automatically the trick you showed until we have a new input device. Or maybe it could help people to get a brand new camera, as you did, give it the Windows driver, which is obviously provided with it because the Windows set is much more bigger than the Linux one, and then automate all the detection and to say, okay, this ID is the one we are looking for. Mm-hmm.
So you're suggesting a script which parses the Windows driver and tries the combinations for the USB IDs and check if it gets something to work? Maybe
passing the INF file which is given with the camera, and then after reading the INF file, finding all the possible association with existing USB device that we already have in the kernel database, and then make your trick to try all the combinations that exist until it works.
Yeah, I think the idea is challenging, and if you like to do that, just feel free. One thing I'd like to mention is that Windows drivers are still binary blobs, so we can't look inside them. And it might be that they have some extra code for some extra camera. So I'd really love, if a new USB ID is added to the kernel as a patch, it should be tested on real hardware or not on speculation. This is what I would suggest. But it's really useful to have these files in mind and then look for potential cameras. And you could like try to find people on the net who had problems with that camera and ask them if they could try this line and then echo the ID to a USB ID, to new ID, do what I did here, and then you could check with someone who has a real hardware and then add the support to Linux. Doing that totally automatically is not my preferred style. There.
Hello.
Hi.
I think there are a lot of USB devices. Are there unknown USB IDs? And what about non-public specifications? Did people try to fudge the input data to send random stuff to a USB device in order to see what they get back?
Not that I know of. But this is a side project. I'm not really an USB expert. I know that there are some companies using USB numbers with which they shouldn't, but it's not. It's just laziness. It looks like a sloppiness or laziness or something in between. What I do know most is that there are still a numbers of USB ID missing descriptions, like expensive cameras. If you type LSUSB, you just see the vendor but not the product name. So I really call again for crowdsourcing. Check your USB devices, check if they have proper names, and maybe submit them to the USB ID list. That would be really great.
Okay. Hi. Thank you for this talk, and it inspires me to do something myself. I have a camera at home, but the thing is, I know already that this camera must have some initialization routine to get the webcam modus on. So what I need to do is I need to have some, tracing also for the USB protocol to see what is needed to get the camera into this webcam mode. So for sure, I would have to do this on the Windows where the drivers are running. Is there any tool that you can suggest to do such USB tracing?
I haven't done that myself. There's USB snooping software for Windows. So they intercept the USB stack and print out what has been sent back and forth. I think it's called USB Snoop or USB Snoopy or something like this. There is also hardware. They're more expensive. They're quite expensive. Very convenient, but quite expensive. Maybe I don't know of any free hardware, but we might be just lacking the information here. But there is. What I know, there is software for Windows which intercepts the stack, USB stack, and prints you the communication between the cam and the Windows host, and then you can re-implement it on Linux. That sounds good. Please do that.
So, one point about USB tracing. You can also run a virtual machine with Windows on it and try Wireshark with USB Mon, and then you can show the tracing.
Look. 3, 2, 1, last chance. Gone. So, thank you very much for attending and have a great conference.
Thank you very much, and we'll continue here in Janson at 3 o'clock with your application versus GDB.